Nick here, M0NTV, and welcome back to my shack and to another video. And well, the festive season is almost upon us, but before I get sucked into a whole series of carol services and everything else leading up to Christmas, I thought I could just about squeeze another video in, so this is it. And really what I wanted to do was to finish off this direct conversion receiver. We spent a lot of time on the audio amplifier and we've been down all kinds of, interesting, I hope, rabbit holes with designing transistor amplifiers and small signal analysis and all that stuff. But today I just wanted to bring it back to basics and do some practical radio building. So that is what we're going to be looking at today, and hopefully I can put this radio together and let you hear it. So I hope that you find something of interest here, and as always, I hope you enjoy. So here is the architecture of my direct conversion receiver. We start, of course, with an antenna, and I'm using my usual antenna, which is my end-fed half wave, which is cut for 40 meters, which is useful because that's exactly the band that we're interested in. So the first stage of the radio then is going to be our band pass filter, and then the band pass filter is going to feed the incoming signal, which by now will just be a 40 meter signal because we'll have filtered out everything else, through to an RF preamplifier. I don't always build RF preamps in, particularly for HF and for something like 40 meters, but I'll say a bit more about that in a moment. But this will be an RF preamp with variable gain, and one which will also act as an RF attenuator if necessary. So I'll have some variability about the strength of the signal that I'm going to be passing through to the next stage, which is the product detector, which of course is a mixer. It's just a mixer which is going to mix our signal down to baseband, to audio. And a mixer is a 3-port device. It has 2 inputs and 1 output. So one input, of course, is the signal coming from the RF preamp. The other is our locally generated signal from our local oscillator, our VFO, variable frequency oscillator, and mine is going to be an analog one. And those will mix down to give us our audio signal, which of course will go into our audio amplifier and then out to our loudspeaker. Now, as I said, we've tackled the audio amplifier. It's these other 4 stages we're going to look at. And I say we're going to look at 2 of them. I'm not really going to look at all because I have covered them many times before, and that is the bandpass filter and the product detector. But I will show you what I've done with those, but I want to give most time to the 2 stages that are perhaps a little bit different and I haven't tackled before, which is the RF preamp and the analog VFO, the local oscillator. So 2 things I'm not going to go into the details of here because I've done them several times before. First of all, the band pass filter, and so this is just one I built some time ago for 40 meters. So it's the classic Hans Summers design from QRP Labs. That's, he didn't invent it, but I used his instructions for doing it. It's the classic double tune circuit here, which works very, very well for me. So I will link to a couple of the videos that I've done about building this. And by all means have a look at those, or if you want to build your own design, that's fine. But you will need a bandpass filter. And they can be tricky, but once you've built a few of them, you get into the idea of how they actually kind of operate. And yeah, it gets a bit easier then. But yeah, so that's the bandpass filter. And the other thing I'm not going to talk about, because I've talked about many times before, is the product detector, which is a double balanced diode ring mixer, and I've done even more videos, I think, about these. So I'm not going to talk about those, but I will link to a couple of videos I've made about building this, because this has the W7EL Roy Llewellyn audio diplexer on the, well, what's the AF port would be the IF port in a standard mixer, but where the audio is going to come out from. And that just helps with the carrier suppression, and that I did a lot of testing on that actually in one particular video. So yeah, so passive diode ring mixer, and again, yeah, I mean the main thing with these is just learning how to wind the trifilar transformers, but once you've mastered that, the rest of it is not too bad at all. So, and that's what I'm going to be using for my product detector. Now, in a direct conversion receiver, virtually all of the gain usually comes in the audio stage, because obviously we don't have an IF stage where we would normally do some useful RF amplification. And as you know, my audio amplifier is not the most powerful amplifier in the world, so I'm not getting quite as much gain there as I perhaps would normally. Also, I'm going to be using a passive product detector, a diode ring mixer, and so that has no gain. In fact, it has a loss. So I decided, unusually perhaps this time, to have an RF preamp, even though it's for 40 meters, just to have a little bit more upfront RF gain to make up for some of the losses and lack of gain further down the line, so to speak. And so what I settled for was a design by Wes and Bob. You remember they famously created the Termination Insensitive amplifier. I've built it several times. I know Bill Mara is a big fan of that as well. I think he's got at least 4 of them in his current rig. The only problem with that is it's a fixed gain, and to kind of remedy that, not all that long ago actually, Wes Hayward decided that he would have a look again at that design. So he created a new design with an extra stage in it that would enable the gain to be varied. Now, I think he had in mind to use these in an IF stage where you could feed a control voltage back in, say, from the first stage of the audio amplifier to beef up the RF amplification in the IF stage. Obviously, I've got no IF stage, it's a direct conversion receiver, so I thought what I would do is I would use his design, but actually I would create my own control voltage and vary it with a potentiometer, and then I could have, as it were, a manual gain. And the great advantage with this, of course, is that it is a termination insensitive amplifier. So I know even when I adjust the gain, I'm not going to stuff up the input and output impedance. Now, you will have noticed, hang on a minute, that's a PCB. It is. A little while ago now, Todd of Mostly DIY RF very, very kindly sent me a package of some of his incredible work and the boards that he sells. And one of them is this design that Todd created his own PCB for Wes's design. And I thought, well, this is the perfect opportunity to try it out. They are excellent. All his work is excellent. He's got a whole range of different designs. I will link to Todd's website. And yeah, just fantastic. And I thought, well, it's great because the thing is, with Todd's PCB, I can build it a lot smaller. If I was building this Manhattan style, it would be 3 times the size of this at least. So that's quite good. So that's what I did. Now, what I built here, you'll see, is a little daughter board on top. And all that does is the 12 volts comes in here and feeds Todd's board. But then I'm tapping off that 12 volts down to a 5 volt regulator. And that 5 volts then is being varied by this 10K pot to give me some different amounts of voltage which will feed in and control the gain. So this is my gain control, my manual gain control. And actually, that seems to work really well. So on days when the signals are all loud and everything, you can turn it right down, not worry about it. And on days when you're struggling, you can crank it up a little bit. So yeah, and as I said, it goes together pretty well, and much smaller than I would normally build. So thank you very much, Todd. And that will go in my direct conversion receiver. And one other thing to say about this, I did some tests. I'm not going to show you all the tests now in the interest of time, but just to say that with the potentiometer turned right down, so the resistance is absolutely minimal, I can get 22 dB of RF gain from this amplifier. So that's the maximum that I can get, which is great, ideal for a little RF preamp. That's just perfect. But of course, there's a fair bit of variation I can get by turning the pot. So actually, looking at the extremes of the potentiometer, I've actually got a span of, well, 50 dB difference. Now, it's not a 50 dB gain, of course. I've only got 22 dB gain. That's the maximum I can get. But most of that 50 dB will be attenuation, of course. But again, that can be a useful thing. So it means I can actually vary the signal going into the product detector, by up to 50 dB. So if the signals are really strong, I can use this as an attenuator to reduce the strength of the signals. But also then I can dial in some amplification when I need a little bit more of a boost. So very pleased with that, and I think that will serve me well. And so this is Todd's schematic for the Wes Hayward and Bob Kopsky variable gain tier amp, and I think Todd calls it his tier IF amp or AGC amp. And you can vary the gain, as I said, mine's got 22 dB, which is about the most that you'll get out of this, but it all depends on the values of 3 different resistors in this first circuit here, R1, RF1 and RD1, and depending on the values of those, you'll get a different maximum gain out. So by all means, do have a look at Todd's website and check out some of his designs and his boards if you're interested in that. Now, the design that I'm using for my Analogue VFO is the Franklin Oscillator, and I'm using the design, and this is the design of Charlie Morris ZL2CTM, and this comes from his notes that he makes freely available on his blog. I will link to the videos that Charlie made about when he built his Franklin Oscillator, but essentially it's two 2N3904 transistors. You've got 2 circuits here, and they are very loosely coupled by this, what he calls CG, the gimmick capacitor. So called because really it's not an actual capacitor in many cases at all. It's just 2 pieces of wire that you twist together and trim just to get a very, very low level of capacitance. And one of the reasons why this design is so stable, I think, is because all the tuning elements are in this circuit here, which is only very loosely coupled to this bit. So actually there's a kind of buffering effect that goes on here, and actually even more so because there's another little design which is not included in this drawing. It's on another sketch, which is a little buffer amplifier, because actually this produces a signal, but it's a very low level signal and it's not powerful enough to drive something like a passive diode ring mixer, which is what I'm using. So you need to amplify the VFO signal in order to use it with that. And Charlie does that as well. So there's full details. So I'm not going to go into loads of details about it because he can explain it far better than I can, because it's his design, really. But it's, I mean, just look at it. It's really very simple. One thing you will have to do, and we've got here just the variable capacitor. In truth, it doesn't look like this. There's extra series capacitance and parallel shunt capacitance as well, and that has the effect of reducing the range depending on the value of your variable capacitor, and also kind of nudging the whole range up or down in frequency, so you can get it exactly where you want it. So it's a useful thing. But he explains all of that, and that's in some of his other designs. So that's the basic thing. So let me show you what I actually built. And here is my Franklin Oscillator in a very appropriate Merry Christmas tin, oversized tin, but I'm thinking I might actually try and build the whole radio into this tin. So it's down here, so you can see my variable capacitor obviously here, and kind of focus in, you'll get an idea. So there is some padding of the variable capacitor. Some of that is series capacitance and some of that is parallel capacitance. And I've got some little trimmers there, one there and one down there. You can see my coil. I needed quite a lot of turns. If I can get around here and really get a better look at it. Quite a lot of turns for 40 meters. When Charlie Morris was doing his, he was doing it for an IF stage of, I think, about 10 megahertz. So to get down to 7, I needed quite a few more turns, but that's fine. So that seems to work okay. And I built it, other than the faffing around with the levels of capacitance, and that will depend, of course, on your individual variable capacitor, and depends what the values are and everything else. So there's only one way to do that, really, is to kind of try it out and see what works for you. But other than that, I built it pretty much to Charlie's design, including the little buffer amplifier, which is this bit down here, which essentially just beefs up the signal a bit before it goes into the product detector. And you can control the levels of that with this little trimmer variable resistor here. So that's good. So you can dial in the 7 dBm or thereabouts that the double balance mixer will require. And yeah, so that's it. It didn't take too long to build. The thing that took the longest really was just the physically attaching the capacitor, because obviously that's the biggest and heaviest bit on the board. But it's built Manhattan style, as you can see, with the little kind of me squares, and the whole thing's then attached to the enclosure. So I've got a couple of screws there and there, which is where the board is going through there and there, and then the actual capacitor itself is soldered down with a fair bit of solder actually onto there, which seems to be pretty secure. So that is what it looks like. Now you will recall from the schematic that the design calls for a very, very loose coupling between the two stages in the Franklin oscillator, and very often that's done with what we call a gimmick capacitor, which is basically two wires just twisted together, and depending on how many times you twist them, how long they are, how close they are, etc., you'll get a different level of capacitance. You only want a tiny amount. So I chose a different way. So what hopefully you can just about see here, I've got a little string here of 1, 2, 3, 4, 5. You can see the bottom one where that orange wire goes down. 5 series 1 picofarad capacitors, right? So 1 divided by 5, so that's 200 femtofarads. Is that what it is? Yeah, so a tiny amount of capacitance, and those are NP0 caps. And that seems to work just fine. You just need a tiny amount, and I couldn't really be bothered just for faffing around, trimming wires down, whatever. So I just experimented with that. But that seems to work just fine. The only other thing to mention about my particular design as well is, for reasons best known to itself, it tunes backwards. I think it's probably the way I've connected the variable capacitor in. So in other words, when I turn it to the right, the dial to the right, actually what's happening is I'm going down in frequency rather than up. But actually, to be honest, it doesn't really matter. For me, for reasons best known to myself, generally speaking, when I'm on 80 meters and 40 meters, I tend to start from the top of the band and tune down through the band, whereas on 20 meters, I would tend to kind of start at the bottom and tune up. So I don't know why that is. So that suits me fine, really. So, but I just thought I'd mention that because I guess, it depends on the design of your variable capacitor and exactly how you connect it. Okay, so first test we're going to do is the bandwidth. So keep your eyes on that figure at the top right, the M1 marker. So we're at 7.075. I'm just going to turn the variable capacitor just very slowly now, and you can just see we're tuning up in frequency, and it looks a bit jerky. That's just an artifact of the video, but actually in truth it's really very smooth. And we're going to go all the way from 7.075 all the way up to 7.2, the top of the UK allocation of the 40 meter band, and it tunes very easily. It's a little bit picky and sensitive, so you can cover an awful lot of ground by not moving it very much. There may be something I could do about that, but that works really very well. And the next test that we're going to do is the drift test, and you will see that the center of our spectral display is 7.1 megahertz, and you'll see that actually we are at, well, just 100 hertz north of that 7.1 megahertz, and I've got the waterfall display down the bottom. So the whole span is only 2 kilohertz. So each of those vertical divisions that you can see corresponds to 200 hertz. And you can also see there's an upward drift, but not a great deal. And there's no temperature compensation or anything like that going on in this design. It's in a metal tin, but that's about it. So the things run for about 5 minutes, certainly no more than 5 minutes. So it's it's settled down a little bit, but not bad, all things considered. Right, here we go then. So we start with the RF coming in from the antenna into the bandpass filter. And then from the bandpass filter, we're going to go over to the RF preamp. And then the RF preamp is going to feed into the product detector. And the other input on the right hand side of the product detector is coming from the local oscillator, which is my Franklin Oscillator there. And then the output in that audio cable is going all around the back of there, bit of a circuitous route here, and round to the audio amplifier and the loudspeaker. So that's it. I mean, you couldn't occupy more physical space if you tried, really. And as I said, you know, if I was really minded to, I could put all of these disparate stages all into this one compact little tin, and that would obviously make a lot more sense. But just so that I can demonstrate it now, this will do for our purposes.
So, but it's that time of day, isn't it? I think the band's not necessarily been the best. Okay. And there's the Continentals will now be flying in, won't they? So look out. No, I tell you, we've had our fair share of weather this last day or so, haven't we? It's gone from one extreme to the other. Mine, whatever, freezing cold to quite mild, blowing a gale and rain. So, although we didn't quite get the winds that the weather forecasters said we were going to have, that didn't actually arrive. Windy, make no mistake about it, it was windy, but it wasn't as bad as the weatherman suggested it might be. So there we go. 20 KAX M0 VDL.
Had a bit of string on it, so but that's great. I was disappointed in the first round. You can't, you know, it was a 17.
Yes, 100% correct. Papa Alpha 3, Echo Queen Alpha, Germany 4, Yankee United Mexico. Good afternoon. Good evening. My name is Linda, spelling Lima, India, November, Delta, Alpha, Linda. Microphone for you.
Many thanks. Echo Cuba Alpha returning. My name is Johannes, Juliet Oscar Hotel, Alpha November, November Echo Sierra. My security is Juliet Hotel, Echo Echo, Romeo, Alpha Echo, in the middle of the Netherlands. And go ahead. Alpha 3 Echo.
Okay.
Well, there we go. Another direct conversion receiver built. Well, come 2025, I will be embarking on some new radio electronics projects. So if you've enjoyed this video, then please do like and subscribe, and you can keep up to date then with all the stuff that I get involved with. Thank you to everyone who has supported this channel over the past 12 months and has watched the videos and left comments, and I really appreciate your support and your encouragement. So thank you very much for that. And can I wish you all a very, very happy Christmas and a peaceful new year. And I will catch you in 2025. But until then, look after yourselves. 73. Bye-bye.